Hey guys, we're going to continue with lesson 2-4, and we're going to be talking about types of solutions. When variables are on both sides of an equation. Let's see, are on both sides of an equation. So we're going to do kind of some diagrams and then an example problem, okay? So we kind of talked about this conversation before, where when we solve equations, we have three possible outcomes. And the first one is the one that we expect. We expect to get one solution. For most of our equations, there's only going to be one solution. So let me give you an example what that might look like. So let's say we have these boxes. Okay, and they're sitting on a scale. So here's a tip point for it. And we have this. And somehow those four boxes balance with two identical boxes and a 6. So how we would interpret this would be each box would represent some unknown amount. So we're just going to call it 4x's. And the balance point is saying on what's on the left of that point is going to be the same as what's on the right side. So we have two empty boxes, mystery boxes. We don't really know what's in them. And then there's a 6. So when we solve this, we're going to do inverse operations. And we're going to get all the variables on the left. And that would give me 2x equals 6. And we divide by 2. Oops, let me try that. Do that in a different color. Divide by 2. And we get x equals 3. So the result is if we had that scale, that one box would be the same as a box that has 3 in it. So we have exactly one solution. Okay, and again, that's what we expect to see. All right, next, let's talk about it's a possibility that you have no solution. So again, let's kind of draw this out. Again, we have a balance point, and we have an empty box, or we don't know what's in it, and a 3, and then we have an empty box, and we have another box that has a 5 in it. So if we interpreted this, this would be x would represent the empty box, plus 3. The balance point is in equals, and then we have x plus 5. Now let's say we wanted to get all the variables on the left, so we would subtract. And what happens in this problem is that the variable gets eliminated. Okay? So we get 3 equals 5. And the question you have to ask yourself is, when does 3 equal 5? And you say, it never equals 5. 3 can only equal 3. So, again, key to remember, variables are eliminated. So anytime variables are eliminated, then we need to figure out how to interpret our answer. Okay? And the second thing that happens in this particular situation is that the resulting numerical equation is never true. Okay, so we know that 3 is never equal to 5. So when you attempt to draw this solution, you really don't have anything you can put on there because you don't have anything that's true. So there's nothing that balances because it doesn't make sense. So you would say there's no solution, or you could do 0 that way. So again, that's a second possibility. So the first one, the variable is part of the problem. The second one, the variable gets canceled. And then we have a third one. And the third one is we have infinite solutions. Okay. And so in that picture of our balance, we're going to have a box, our mystery box, and then a second one that has a 4 in it, and it's balanced on the other side by a box and another box with a 4 in it. So if I interpreted that, we would say x plus 4 equals, that's our balance point, x plus 4. And again, if I sit there and try to get the variables on the left, and I subtract x from both sides, the x's cancel out, and we get this as our answer. 4 equals 4. So you might say, well, when does 4 equal 4? And the answer is, it always is. Okay? So again, what you need to pay attention to is that variables are eliminated. Okay? And the resulting numerical equation is always true. Okay, so if I drew a picture of the situation, we have a balance point, and we have a mystery box, and it balances with the mystery box. Okay, so how we would write the answer is we would say all real numbers. So that means any fraction, decimal, rational, irrational, all of those would be considered actual numbers. We have that cursive R that we can use. We have an identity. Okay, those are all 3 different ways of writing the same answer. There is one when you have the situation of a system of equations, then you're going to get another way of saying the answer would be infinitely many solutions. Now, I'm not going to write that down because we'll get into it when we talk about that. So that's it. So if we keep a variable in, we're going to have, generally speaking, one solution. When the variables get eliminated, either we're going to have no solution if what's on the left doesn't equal what's on the right, or we're going to have an infinite amount of solutions if what's on the left is identical to what's on the right. Okay? There you go. Good luck with this, guys. Bye.